Welcome to everyone here in the room and out in Zoom land. Um, our yeah, everyone's mic and out in Zoom land's been muted. So if you need to say something later, you'll have to unmute yourself. And I only have a couple of opening comments. One is that, yes, we are working on the 2-meter repeater. So progress is being made slowly, but it is being made. And the second comment has to do with our team is working on the locker to straighten out all the donations we've had. So those things are in process. I need a volunteer for when people want to ask questions or something to pass around the microphone. Thank you. Got that taken care of. Do we have any first-time visitors tonight? Anybody new? No? Okay. Anybody got a new license lately? Okay.
Yeah, John Bowie here in 5CLS. I've first time at a meeting and a new member since about 3-4 months ago.
Welcome. Guest I couldn't hear. Sorry. Our presenter tonight is Chuck Abramson from ABR Industries. They make cables, all kinds of cables. And we're going to turn this over to him momentarily. Rumor has it that he was once a member of the club here, although I can't confirm that. Perhaps he will. Chuck, are you with us?
I am.
Okay. Here we go. So I'm going to stop sharing my screen. And why don't you go ahead and share yours and see if that works?
All right.
Oh my God. Chuck, take it away.
Let's see here.
Oh.
Screen sharing.
What happened? Share one. There it is. You're back.
Oh, come on. No. Right. Let's see here. Why is this not? There we go. Sorry, guys. I had it on the. Let's see here. And. All right. So hopefully everybody can see my presentation. And here we go. Yes, thanks everybody. I'm Chuck Abramson with ABR Industries. I was a member of the club back in the 90s, 2000, early 2000s. I was with a company called Cable Experts back then. That was another company that I had worked with. My father and I had started that business back in 1989, and we had sold that off in 2004, 2005 timeframe. So since then, kind of been moving around helping a few friends with their companies, but always kind of had a hand between amateur radio. And then when the non-compete was up in 2010, my father focused on starting up this venture, and my brother and I and my sister-in-law kind of had our hands in the pot since then. And back in 2019 then, my brother Ben and I came on full time. Shannon was there in 2014. So, just a quick overview. Just talking about cables for what's right for the station. There's a lot of choices out there. There's a lot of choices with my organization, my business. Sometimes it just comes down to how much power you're running, what type of antenna, tower, wire, vertical. Some of the installation considerations: is the cable hanging loose? Is it something that you have to put away and hide from the HOA? Is it something else that's going on there that you're worried about? Animals, birds, somebody getting a hold of it? So some things to consider there. I'll talk through some of the popular connectors that are out there in the marketplace. Most people know them, but it's always just a quick review, and then kind of chat about some of the other products ABR Industries offers. some things that you may or may not see on here. If not, we can always take questions because, like I said, there's quite a diverse set of things that I wind up doing. So what is my baseline? What do I offer as a standard? All of my cables are outdoor rated. They're UV resistant, non-contaminating, which means it's suitable for direct burial. The average lifespan of the tested cables is 20 years. We go through some special UV tests, some stuff for mil-spec testing, and then I was talking to a gentleman. We work very closely with the mills or a mill down south in the south here, and they actually have a field where certain cables are buried over a certain period of time and brought up and tested. So there's a lot of stuff that we wind up doing there, and then some of the questions based on also what is your usage and what's important to you, whether it's a bend radius, an installation issue. The goal that we have is when you buy a product from us, whether it's a cable assembly that's finished or not, we want you to get your project taken care of and set it and go operate and play radio. We're hams as well. We don't want you thinking about it and worrying about your cable. Obviously, there's always checks and balances to your system periodically, but for the most part, we want you to be happy and just plug away. So I'm just going to take a very generic example of the 100-watt system for HF. Really kind of the old PB&J, a standard that's out there for a lot of people. And there's two popular cables. I'm going to start with the simplest one, which is what we call our 240 Ultraflex. What happened was the RG8X product that everybody knew, Belden created that back in the 70s, and they did a phenomenal job of promoting it. But they promoted it heavily as a automotive type of cable. And when the amateur community got a hold of it, we could find that we could make base station applications out of it happen. And because the pricing was always so attractive, it was a great product that went on for a very long time. With one key change, which was the dielectric, we went from an old, what's known as chemical foam, to what's now known as a gas-injected foam, or an 84% velocity product over a 77% velocity, which means we got about a third better in the losses. So it was kind of a hard stop from my standpoint in the organization here was with the mill. What else could we improve upon the product if we were going to just change a dielectric? So with that, we decided to make a lot of our flexible products as high of strand count as possible. So instead of focusing on the traditional 7-strand, we actually do a medium drawn 16-strand. We obviously changed some other things. We put a foil on there as a standard and created the 95% tin copper braid. And the final piece was with the jacketing, because that standard jacket that I told you about, it was really just playing with pennies at that point. So this is kind of the replacement from an old traditional 8X. And I know it can be confusing because there's always books out there and information, and that's what people are used to. So if you call us looking for it, we refer you to this product. We explain some of the changes, but it's an exceptional product. It's easy to flex and twist. It's for installations. It's a good product. If you're a new ham or a seasoned ham, whether you're upsizing or downsizing your shack, if you're looking for jumpers, this cable really covers a lot of ground. The loss characteristics are good. There's better products out there, and I'll get into them, but it's a good piece for using at home and out and about, or out for POTA, or in your vehicle. And even when a cable gets old or something happens to one of the connectors, you can even chop it up and make a pretty good set of jumpers and other cable assemblies out of it. So this is one that realistically, from the amateur market, is about 40% of our volume. If anybody's curious what that means in footage, it's a little over 3.5 million feet we sell of it every year. And then we have a sister product, which is the solid product. The reason why I like to jump into this one next is for a lot of people, they have stationary antennas. Some people still have the rotors, tribanders, and the bigger setup, but because a lot of people have had to crunch down where they live and their size of their lot, the solid product is still 10% less loss than stranding, and it's due to the capacitance of the center conductor. But the nice thing about this product is, A, once you set it and forget it and move on, B, the insertion losses are still pretty reasonable, and as far as pricing goes, the solid or the stranded is still fairly economical in comparison to some of the bigger stuff, especially if people have been watching the price of copper these days. It's gone up quite a bit. Just to give some insight on that, copper just a year ago was about $5.25 a pound, and now it's about a little over $6 a pound. So it's a big change out there in the market. And unfortunately, things that are going on in South America kind of been dictating some of that price change. I think it's steady, and I don't mean to scare people, but it's one of those things that unfortunately did take a jump. So just using those two small cables though, side by side, and getting back into it, this is kind of where it becomes a little bit key in the sense that, you know, the test results that we produce is the industry standard 30 meg, 50 meg, 150 meg, 450 meg, so on and so forth. But from HAM's standpoint, you know, we're operating, 20 meters at 14, we're operating 40, we're doing a little bit less than that at 80, and sometimes we jump up from there. But overall, you can see here that if you can keep your system around a dB or less, you're doing fairly well as far as the cable goes. And sometimes people can get lost in the numbers, myself included, but you can see here that these are two products that really could do an awful lot for a lot of people out there. But then I'm going to take a little bit of a flip side now and say, okay, let's introduce a little bit of power and start to jump up to the bigger cable, which then gets to our other popular product. This is kind of the number 2 item, is our 400 Ultraflex. And with our 400 Ultraflex product, where did it evolve from? RG8. All cables really start from an RG number, and that was done by the military back in the 30s and 40s. But RG8 really kind of blended into what you see here from a 400 series. Where does the 400 come in is just the 0.405 OD. But that's one thing that has definitely had a life of its own. But it gets expensive sometimes because it is a pure copper stranded center conductor. And like I said before, we use that 19 strand center. And you can see there with the high velocity foil and braid, it's definitely a nice product. It's a low loss product. It has a lot of applications. So if you have an HF radio that does HF but also VHF, UHF, it might be a consideration to look for that product. Or if you're looking for a setup for 2 meter 440 and you've got a longer run, that's also potentially another item that you could look to. And then also looking at items that are lower loss, this is one of those that does it and gets about as good as it can get as far as the insertion loss for the size of the cable. And the coverage is great. Also, if you're a satellite operator, this is a great product for bending and twisting and constant flexing. This cable is designed to be flexed 5,000 times before there's any migration of the center conductor. So that occasionally comes up as a question to us. And then there's the sister product, which is the solid. And this is where it gets a little confusing because Times did a great marketing job when they introduced the 400 as a product to the market. Now, I will tell you, Times was not the company that created this item. They were the ones that borrowed it from Belden. So when you really look at this, Belden actually developed this product first and foremost, and it got copied with a number of iterations based off of what Belden called 9914, which was a foam product of what people remember the old 9913 or Aircore product. Some of the changes that were made was a copper over aluminum center conductor, and the reason being was purely based on weight. Nothing else. Obviously, everybody knows about the skin effect, or hopefully has heard about it. And with the right amount of copper on the center there, you can pump an awful lot of power in there with very little change in your RF performance and still make it about, yeah, I would say, it's in the neighborhood of about 30-40% lighter than its pure copper cousin product. So definitely something to obviously see and take into consideration when you look at that. But it's still a very economical product as a solid center conductor. This is also less expensive than the stranded version that you see out there. And it's a good feeder cable, especially if you're doing a longer run. You can use this as your trunking line up the tower to a certain point where you can use the flex for the rotor, and then over to the shack where you can plug it in, whether it's your lightning protection, and then obviously run smaller cables in the shack itself or continue on with the Flex 400 series. The other one I like to throw in here, and it's sometimes just because it's been such a popular product over the years, which is the 213. A lot of people recognize 213. They've used it. They've had a lot of success with it. It has been around for a long time. It was a step up from the old RG8 with a stranded center conductor and a slightly larger gauge. The braiding was a 97% copper mil-spec braid. But the beauty of this item is, and the reason why it still sells today, is the dielectric. Even though the insertion losses are a little bit higher, and I don't recommend this for above 6 meters, but yet 213 can take an awful lot of heat and generally speaking just kind of wipes it away. And part of this is just because of the way the military really required the designation, and for the product it's still somewhat popular today, but it's just an item out there that's designed to last for an extensive period of time. And what I mean by that is, nowadays when the government sends me a spec on this product, they require a 30-year life, which this product does test to. And it's just because it can just do so much and last forever. So kind of comparing the big guys side by side, once again you can see here you're just playing with a few tenths of a dB across the board. And essentially speaking, this is at 100 feet of course, but overall when you look at the products, the cheapest one of the three is actually the 400 because of the center conductor. The 213 and 400 Ultraflex, because they have copper center conductors, in this day and age actually winds up being a little bit more expensive than the aluminized copper core of the 400. So kind of a little bit of a hint, and we want to obviously take care of you guys not only from the standpoint of getting you set up, but looking at your pocketbook. It's one of those things to seriously take in consideration. So a little bit of a kind of a high-level piece at this point is you can always mix and match. I know some new hams get stuck on one particular product and want to carry it all the way through, and that's okay. But you know, using a solid center as your main line, your trunk, is always kind of a good way to get it done. It saves you a little bit of money, helps you in the insertion loss category, and hopefully you set it and forget it. When you go inside the shack, I know people get sometimes worried about losses, but unless it's an amplifier where you need the 400 or the 213 products, the 240 cables are going to be a lot easier for you as a user. The flexibility is going to be greater. You're realistically just coming out a 100-watt radio into even an amplifier, and some people, myself included, there's not a lot of space on the desk, so always try to make it easier for yourself. And I would suggest using those smaller cables to make those jumpers. Going on a little bit further, for VHF, UHF, obviously base station. This is kind of where the 400 flex and the solid really does make a difference, because you can see here at 2 meters, you're talking about a little bit less than 2 dB for either product at 100 feet. And when you look at the smaller stuff, it doubles a little bit above 3. And usually 3 dB, you're losing 50% of your power, and the trade-offs versus the economics of getting a better cable versus spending extra money on an antenna, in a lot of cases, jump up the cable first. You can still get some good performance out of your antennas. A lot of these at VHF, UHF are 3 dB, 6 dB, or greater, so their performance is good. Depending on your line of sight or what you're trying to do, it's something that you can get a higher level of performance. The shielding is also good as far as the isolation. I think I kind of skipped over it or glossed it a little bit, but because of the 100% foil and the high braid count that we put on there, we actually get in the neighborhood of about 85 dB of isolation. And for coax, that kind of is a top out as far as the performance goes. There are some double braided products that can go higher than that, but those are usually Teflon based or silver based products, and sometimes become extremely expensive and not practical for feeder lines. But from the standpoint of working this stuff for amateur radio or the general use, these products really do make a big difference. But I would like to throw out there one caveat, which is, I want to show an example here where what is the breaking point between the smaller cable, which is this 240 product, and the 400. So let's do a side-by-side comparison at 50 feet. It's not unreasonable for some people to have this, especially if they're getting started or if they've got a smaller setup. But between the two cables, generally their physical characteristics are just generally the same. But as you can see here, for the 400 product, you're getting about 40 watts out on 2 meters and 24 watts out on 70 centimeters. In comparison, it's only a small difference for 34 watts on 2 meters for the 240 and 17 watts on 70 centimeters. Now, for some people, they say, well, it seems like a lot, and technically it is, yes, a significant number. But depending on where you're located between who you're talking to or what repeater you're working or what you're operating on, sometimes the means and ends are you can still do an awful lot with the smaller cable, and when the cable starts to fail or not work properly, then maybe jump to a bigger cable from there. So sometimes a good, better, best is a lot closer side by side than sometimes people realize. The other component is portable. A lot of people are doing POTA nowadays. They're getting out and about, and that's great. And this 240 product, we really kind of find a huge popularity with. It's an easy cable to wind, unwind. You can get a little handheld winder for $10 out of Amazon if you want, or you can physically hand wind it. And it's designed for repeated flexing. The losses are great, as we discussed or saw earlier. It's a good outdoor rated cable. Not only sun, but it can get rained on. It can handle cold, warm temperatures. It generally can be used in just so many different areas when you're doing portable work. And for a lot of people, this is really a good cable in the sense that it covers a lot of ground. I hear a lot of hams sometimes talking, well, some hams I should say, talking about carrying the 400. Please don't do that to yourself unless it's like field day and things like that. I think sometimes, it sometimes gets lost in the numbers, but it's a lot of stuff to lug out there, and the cable shouldn't make it more difficult than everything else. So that's kind of the comment there. And then the soda crowd, and this was kind of pushed a little bit from the help of some of the YouTubers out there. The 316 that we had became an incredibly popular item because of a few key characteristics. One was it's lightweight. So when I talked about that 240 product, a 50-foot cable assembly weighs in the neighborhood of about 5 pounds. This cable, generally I would not recommend it for lengths longer than 35 feet, but it's only weighing about a little over a pound at the 35 feet, and that's with the connectors on there. It is a stranded product. It does have some flexibility. I know somebody might be raising their hand and saying, yeah, I've worked with Teflon before and it's a little bit stiff and it has a memory. Yes, it does. We do sell a 174 product, which is very flexible if that is an issue for you. So we do kind of have a cross product there. But the 316 is crush resistant, so if somebody steps on it, or if you're operating and all of a sudden it's raining and you got to get into a car, but you're still trying to finish up a few QSOs, you can put it into the door jamb, you can get it stuck in the car door, it'll always come back. Some people might have also noticed that 316 is becoming more popular with some of your antenna mounts, and that's part of the reason also because of the crush resistance and the ease of use. It's a lightweight product if you're traveling, if you're doing vacations, if you're trying to do a little vacation with the family and have a little getaway time. It's an easy lightweight cable to hide in the backpack or put in the bag, and with some of the portable antennas out there, you can definitely make a go of it and still have a little bit of side fun with the family or doing it kind of on your own. I don't want to tell you to be a hermit, but this is one of those things that a lot of people like for those different applications, and it's easy to use and take with them. As I mentioned before, it does come down to length. Generally speaking, you can see here the reason why I recommended 35 feet is just because at 30 meg, you're kind of getting close to half your power. If you're a QRP person, I know you're probably getting the shakes right about now, but even if you're a CW operator, you can still make the most of it with this cable. You don't have to use 35 feet. In a lot of cases, we sell a lot of 15 footers, 10 footers, 25 footers to get the job done. But if you're starting to push this length, I sometimes will recommend starting to move over. One other little comment here is when you look at the cables, the one thing is the 316 will handle over 100 watts just as much as the 240. Yes, it is smaller, so it will get a little bit warmer on the connectors, but it still operates fairly well. So I would say from you as an operator, it just depends what sometimes the key characteristics or criteria is for you, but definitely easy to kind of consider one as a better, best, and it may be based on your setup. Sometimes it's a bench setup or park setup, tabletop, where the 240 is a great product. Other cases, you're doing a little bit of backpacking or hiking in the woods or climbing up a mountaintop, obviously, and trying to save every pound. The 316 is a good product from there. I'm going to switch gears just slightly and start talking about the connectors out there in the marketplace. Like I said, this is really, just like cable, a very old topic, but still important because sometimes it can get confusing because it is just an alphabet soup to some people.
Hey Chuck, it's
Yes,
Brian. Can you crank up the volume on your end a little bit? Is that possible?
Let me. Is this any better?
Oh, God, yeah.
Okay, sorry about that, guys. The first is the PL259s and SO, the female. For those people, obviously, that aren't aware, which I'm just going to take for granted, we look at it from the pin as the center conductor, as the male portion, and not the body itself. If you're a plumber, you're probably hating this conversation because it's backwards from what you're used to, but it's a pretty straightforward piece that was done many, many moons ago. It was invented in the 1900s, early 1900s, by a gentleman that worked for Amphenol. It was a way for them to deal with coax, to try to get away from open wire lines where they had problems with noise and other things were starting to interfere as the spectrum was getting busy. And it was an easy, quick connection that was designed to have several matings. And it's obviously still been around today. We've done some redesigns to the product. One is we increased the size of the center conductor to handle the 400. What does that mean is that old 213 that I showed you was a 13 gauge center, but the 400 is a 9.5 gauge center, so it's a little bit bigger. We started looking at other types of connection processes for it. We still offer soldered centers on everything, but we offer still the traditional solder weep hole version and the crimping. When we talk about crimping, we're not crimping it by hand. I think one of the gentlemen I was talking to earlier, talking about the process, we're a highly automated organization at ABR, so we have 2-ton presses that actually do the crimping for us. It sounds like it's overkill, but it's designed to, compress it 360 degrees, maximize the conductivity across the braid, but also the strength. We do pull tests, and the crimped connections are roughly in the neighborhood of about 800 pounds before they break away. When we solder them, they're around 250. So any product we produce, we're very confident in, but crimping from a commercial standpoint is almost a necessity based on their needs, and we do a pretty good job with it. One of the other comments on the product was we tapered the center conductor and slightly shortened it by 1 millimeter. Yes, it is technically shorter. The reason why we wound up doing that was at 300 megahertz, the connector acted like a hockey stick with the Visuar, where it was cruising along just a little bit over 1-to-1, and next thing you know, it just shot through the roof. But that was based on the design and how it was mated to the female UHF. To cure that, it was a slight adjustment. Many companies were involved in kind of this as a marketing piece to make this decision. It's not something to shorten or take away the product's performance. The pin still conducts 360 degrees when it's mated to the female. It'll still get full power. The performance factors are not gone. They're all the same. But the stability was much greater, up to 500 megahertz, which was the reason for the change. The only challenge still with this connector, and it's the one thing that I dislike about the connector, is the impedance. Unfortunately, PLs, because of the way they're mated, can go as low as 25 ohms in some cases and as high as 100 ohms. Our goal is to try to minimize that to the neighborhood of about a low of 40 and maximizing in the neighborhood of about 60 or just under it. And when we produce stuff, we test for that and try to get it as close to the 50 ohm characteristic as possible and let you guys take it from there. But it's still a little bit of a challenge, and especially for those out in the field, especially with the number of testers out there and how sophisticated they become and how good they've become, they kind of show sometimes a little bit of the faults in the connector. It's not you as an operator, it's purely the design. One of the other comments is the PL259. With machining, we've got the dielectric as good as we can in there, but we always recommend sealing it. We do put an adhesive line tubing on the back end of the assemblies that we build, and part of that is to keep the moisture out and allow the wicking and the water not to traverse into it. So that's the reason why we do that. There's a little bit of a strain relief, but that really wasn't the objective of why we do that. More or less, we're just trying to keep it moisture free for as long as possible for you, so that when you made it, you wrap it up, whether it's using 3M33 tape or coax seal. There's a number of mastic products that do a really good job of sealing the cable, but Please, if it's a semi-permanent to permanent installation, please seal your connectors, because that's usually the number one issue that I see out there when people sometimes have issues or problems out there. The next piece was the end connector. For the longest time, everybody thought the world stopped at 300 megahertz. Well, the government said, ha, you're wrong. We can go higher. So with that PL259 that I told you had that hockey stick movement, they knew that was going on. So they pushed Amphenol once again and some other connector companies to create the next design, and you got the end connector. So the threading on the end connector has the same thread as the PL259, but there was two big changes there. One was they created a very stable center pin that fits into a snap housing. So if you are building an assembly out there or fixing something with an end connector, when you push it, hopefully you feel a slight bump when you snap it into place. Also, there's a ring that sets the 50 ohm from the center pin. So the mating issues of the PL259 went away as far as the impedance change. And the minimal capacitance bump that was associated with that. It became a really good product for issues with intermod, and we could get really high in frequency up to about 18 gig with a lot of the products out there today. The standard standard N-type connectors start off with a rating of 6 gigahertz, and then there are 12 and 18 gig models out there. So, and there's nothing wrong with the 6 gig model as there is the 18 or 12 when you're talking about operating at 70 centimeters. They're all going to react the same, work the same, perform the same to the cable. So there's nothing there that we're trying to hide, but there are a little bit of differences when we really start to jump up, especially with smaller coax cables, semi-rigid, and other products. But also there's a gasket in there, and the reason being is to try to weatherproof the end because of the way the PL's old dielectric sat. They could build this gasket in there to help it mate up and reduce any water from migrating down the line of coax. BNC connectors. This is one that I hate to say it surprised the industry from a resurgence standpoint. We thought when SMAs came out, they were the cat's meow and BNCs were dead. And boy, a lot of companies prove the wire and cable industry wrong. BNC was originally developed for the handheld devices. A lot of people remember them on their HTs. They're a phenomenal product from 1,000 mating cycles. They're versatile. They're very popular for not only our 50 ohm use, but the video 75 ohm. Those of you that are in broadcast probably see more BNCs in a day than some people can see in their lifetime, but they're just a really, really good product. They were a lot easier to use over the N-type connector, and they had a strong rating up to about 6 gig, which was more than enough to get the job done. The twist lock does have one small issue, which is if you are using this and the antenna is hanging vertically over a period of time, and this generally takes a couple of years, but it's not meant as a permanent connector in those cases, but if it starts to hang, the teeth start to separate a little bit from the spring mechanism on the inside, and the pin slides out of place, and all of a sudden you notice your impedance is going wonky. So it's also a cue to change the connector, but for the most part, people aren't usually hanging things vertically. It's horizontal or off a piece of equipment, so it can last quite a long time. But just a quick comment, we've noticed sometimes guys in the field after a few years a little frustrated with this because that is happening, and it's just, I hate to say it, gravity. It's not you as a user, it's just the way the connector is designed a bit. The last one just putting out there is the SMA. It's become so popular, you see it on every HT out there. You see it on a lot of equipment. You see it on a lot of receivers. It's really just a great piece. It was designed to replace the BNC and TNC connectors with a small thread. The frequency rating got up to 40 gig for a lot of cases. It was originally developed for semi-rigid and the flexible semi-rigid product. It really wasn't intended for coax right out of the gate as we know it. But as the needs grew for this cable, so did the connector opportunities. And so we saw quite a bit of it being used then in other areas with coax. And once the Wi-Fi initiative came about, where they were required for non-standard connectors, and originally it was a reverse polarity BNC, that wasn't practical. And when the commercial mainstream came through, there was the reverse polarity TNC, and some people still struggled with it, so there was a reverse polarity SMA. We do sell a lot of those reverse polarity SMAs. We're very big in those markets. We do a lot of cable assembly work, jumpers, and other products for that industry, those industries. But it's one of those things that it's a good connector. The other nice thing is, from a field replacement standpoint, this is probably one of the easiest connectors. I know that sounds strange being as small as it is, but essentially you can see in the pictures it's 3 key functional pieces between the pin, body, and the ferrule. And crimping is very popular for this with the coax side, but still a lot of users can easily put on an SMA, sometimes more so than even a PL259. So to kind of put a cap on a little bit of this, I'll talk about some of the other things that I offer. We always throw out these pull tabs. Everybody loves them. They're fun. They come on in cables at 25 feet and longer. We make rotor cables for the Yaesu rotors. We also make the jumper kits for the elevation and azimuth rotors. So if you're a Yaesu rotor fan, we've got the cables you might need there. We make braid, 1/2 inch and 1 inch wide. That's a pretty popular item, and we sell a lot of it. The key here with the 1/2 inch is if you have up to about 3 devices, the connectivity curve that you need, the 1/2 inch is more than enough to connect all 3. If you've got more than that, the 1 inch wide up to about 7 devices is key. After that, you start looking into things that are like 2 inch equivalents and stuff like that, but I won't get too deep into it. This has become a popular item. This came out of kind of an area where you can see there a bundled harness assembly, and we bundled assemblies with multi-conductors for a long time with wraps, and we had been doing it even before the ABR days. But the colors came about because I was doing the POTA on the air when the ARRL introduced it, and a young man went running across the field and took my dad's 7300 off the table with him. He said he couldn't see the cable, and as we were scratching our heads, and thankfully the radio was okay with a couple of little bit dings and dents, came up with the concept of coloring these things. The color is the primary reason doing the wrap, but the benefit is actually the wrap is abrasion resistant, and when you're out there, there's a lot of stuff that's out of your control, and if the cable's rubbing out against the ground, the jacketing on just about every cable is soft enough to scar and start to break down to the braid. This addresses that particular issue right out of the gate. So this PTEX mesh is kind of used with scuba divers in other areas. People have seen it all over the place, but it's a nice product. You can make a lot of colors out of it, so you can make it easy for identification. But you can use it, you can beat up the cable, it'll still stay safe inside, and you can get a much longer life. We do build a kind of one and done product for the POTA market where we put the ferrites on there. Obviously the ferrites are to help you with your performance noise floor, and obviously with common mode issues that affect everything FD8, CW. Not so much single sideband, but still important to some people. So we kind of make a universal assembly to make it easy for people. And if you don't like the lengths we have, you can pick any length you want, because we build everything from scratch. So when you tell us go with 33 feet, it's just as easy as making it 50 or 100 feet as far as we're concerned. It's just changing the length on the machine before it starts cutting and stripping for us. The ferrites we offer in 3 different flavors, and the reason being is because a lot of the radios have a limited noise floor. Once we put more than 7 ferrites on there, we've improved the cable as much as we can. Any additional ferrites, yes, they technically do have a performance factor, but they're really not going to help you much. So that's why we limit it to why do we do 3 and 5? Well, if you're sitting out there in the field and the only thing you have is atmospheric noise and you want to address it a little bit, buy the cable with 3 ferrites. You don't need to get the 7. The reason why we did the 5 was it was a good balance between somebody using something at home and being out in the field, but also it just made it a simplistic package so that people didn't have to guess. You get what you need, and like I said, our goal is you plug it in and operate. Get the most out of what you're doing, not worrying about the cable performing for you. We do patch cords and stuff like that, but we also do the ferrite jumpers. We do the inline ferrites, kind of acting as a one-to-one balun like you saw in that other picture. And we do the wrapped toroids. We do them in a wide variety of different configurations, but the toroids that are showing here are designed for if you're running an amplifier or you're having key-up issues. The transformer wrapped effect reacts faster than the inline ferrite. So usually from a transmission issue, that's why we recommend the wrapped ones. From the standpoint of operating common mode issues, just right out of the gate, that's where the inlines come in. I know it sounds a little weird, but it's just how they perform on the curve when we do the key-up testing and some other characteristic tests to check the ferrites isolation. Just to give a sense again on the isolation, 3 ferrites will isolate generally about 15 dB at about 1 meg up to 300 meg with a series 31. The 5 ferrites isolate in the neighborhood of 20 to 25 dB, and the 7 ferrites can isolate generally from 30 to 40 dB. The reason for such the big range is the lower you go in frequency, unfortunately, the more noise can affect you. And I'm sure everybody's seen or heard this, but still, just to say it one more time, we can only perform so much, and that's based on how much can we isolate and how much can your receiver really perform at that level. It's nothing to knock your system, it's just the way the radios are built and the way they're done out there. We do also cat cables. The reason why is because the cat cables we make are oil and gas resistant, outdoor rated, and they're designed to take a beating. We sell them for the trailers and the guys that are using them based on the oil wells. But we found that a number of hams, if you're running a remote station to a doghouse or a small shack or something further away, and you want a heavy-duty cat cable, we can certainly build those for you. And then finally, just to wrap this up a little bit, how do we differentiate ourselves? As I mentioned before at ABR, we've automated our system. 90% of the work is done through the automated tooling. Our ESD stations or workstations are ESD rated. Our people are tested and checked out on soldering different materials between the 4 key people that I have leading the team, and there's about 13 others, but those 4 are rated for everything, including soldering with silver, and one of them, she can actually solder with gold. The testing that we have, we can do a full RF suite of testing. They still, like I said, high pot and continuity test, but that's for the strength of the connection that they put together. Everything from insertion loss, viswar, phase matching, we can do quite a bit. Mechanical testing, as I mentioned before, we do pull tests every so often just to make sure we have a high quality product. There are vendors out there that really work hard with us and do a good job, but we still do checks and balances. On average, my people have about 16 years in the industry. And then the last piece is the materials. We do a lot of vendor checks and balances, go out and visit with them, and do some control pieces with at their plant. So with that, any questions? I know I kind of moved quickly in different areas. I can jump back or just answer as they come.
Yeah, Chuck, this is Mark, WA9IVH. I want to thank you and recognize your company for doing a great job for me on a custom cable about, I don't know, 3 or 4 years ago now. It's a long story as to why I needed it, but I needed to break into the accessory one cable. I think that's an 8 conductor connecting between my radio and my ICOM amplifier. And I needed to break out the push to talk and ground conductors so that I could feed that into the rest of my system and interrupt the PTT keying when the SWR went over 2 to 1. So it was a weird request. What we wound up doing was basically having the equivalent of a jumper, and then that jumper let me go with the existing cable unmodified and plug the one end in. That's where the accessory cables came out. The other end plugged into the amp as needed, and everything's been working great. So thanks for bearing with me on that project, and I wanted to let you know it was a super experience.
I appreciate that, and I do remember a little bit of it because we did a lot of back and forth to make sure I got what you needed right. So
Absolutely, and you did.
thank you, and to everybody else, please don't be afraid to ask. You know, I can look up things. We can look up specs together, double check, triple check, and the whole point is, even if we build something, if we didn't get it right, we'll make it good too. You know, I don't comment sometimes a little bit as I should about my support, but between Ben and Shannon, they're phenomenal. They're very good between the employees and the customers. I will plug Shannon. She will go to the ends of the earth for you. And she truly does care. And it's not that we don't. She is really good at customer service. She is really good at, even if you are frustrated, she will do everything she can to address your needs as they come up quickly, professionally, and really will make sure at the end of the day that, you know, she makes it right by you. So
Chuck, this is Mark WNQZB. Out of curiosity, where does ABR manufacture its coax and connectors?
the coax is built on the East Coast. There's 6 plants. And they don't primarily just do coax, but we help them get started through a relationship. My father had for a long time, and they started in 2000, and we kind of helped them a little bit with some funding for tooling to get our needs done. The connectors, unfortunately, there's really not anything made here in the States anymore as far as the ones that we need. So we're forced to go offshore. We don't like China, unfortunately, because we have to throw a lot away. It's a shame, but it's a fact. We use a lot of stuff that either comes out of Taiwan, because it is a different world over there compared to the mainland China, but also Korea, Japan, and Germany. We have partnerships even with some vendors where we buy actually the pins for our PL259s out of Germany, have them plated there, and then sent over to Taiwan to be finished. So we try to take advantage of whatever we can to not only make the right product, but to make it right by us, so that, because if my people can terminate it easily, other people can terminate it easily, and it like I said, we do take it very seriously to get the job done.
Chuck, I was just wondering, don't you also have a 600 coax as well? And what is that used for? And also, do you have Heliax? I guess I hear a lot of people who have Heliax that they think is very good.
We do have a 600 product, and unfortunately, I thought I had it in the presentation, and I realized as I went, I didn't talk about repeaters. Two things on the repeaters is, yes, we do have the 600, the Heliax. We actually had a good relationship with the people at Andrew Corp for the longest time. So we do build the Heliax, the Andrew product. I am familiar with RFS and other Heliax manufacturers, but usually when you call, I kind of direct you right to Andrew first. The 600 is a good product for longer runs. If it's a ham station over 150 feet, getting 200 feet, the 600 becomes a good product. It is obviously started to jump some of the price up,
Right.
but it's one of those things that, from an insertion loss standpoint and the performance, it's a pretty versatile item. Just so people know, 600 we do use on small repeater systems out there. And the reason why is because the isolation of the the coax version 600 can isolate in the neighborhood of around 95 to 100 dB, but Heliax isolates 120, which is a big difference. And if obviously, the guys that are working on the repeater realize that that isolation can make a huge issue with the desensing and stuff like that. So that's why it's become obviously the de facto standard for that. I will comment that for also, if you have cans that you need to replace the coax on, we do build a lot of those smaller RG 142 400 cables and stuff like that for those replacements. So if you guys run into that, or somebody does, we can certainly help with those products as well.
Chuck, I hate to interrupt you, but I got a time. I do have a couple questions here in the room. We're going to take those questions right now.
Okay.
John, it's Rich, K9RD, and I have a curiosity about something that I read about, never really had any dealing with, but passive intermodulation. Does it ever become part of the design process? I don't even fully understand why it even exists, but in the past, when I worked in commercial systems, that's exactly what they paid attention to.
Yeah, and it's still important. We don't see it much in the ham community at all. We do have tests for it. We usually see it in the cellular and other areas. We can do some of that test, the two-tone test, the multi-testing and stuff like that at different frequency sets. But it's still out there. It kind of comes and goes. Sometimes it's a worry point nowadays because of the manufacturing of the connectors and the other components, and a lot of it is machine driven nowadays. The performance has gotten a lot better, so a lot of those issues that we saw before have kind of naturally gone away. Back 20 years ago, though, it was definitely a hot button issue, because the stamping processes were still out there, and there was a lot of performance issues out there with that.
Thank you.
Okay, Chuck, one more question.
Anybody else?
Don, do you have a question? Anyone in the room have a question? Nope. Okay, Chuck, thank you so very much.
Appreciate it.
Appreciate it.
I will stop sharing and let you guys run your meeting. So thank you very much for your time, guys. I appreciate it.
Thanks, Chuck. Much appreciated.
Be well.
Thanks, Brian.
73.
All righty. Let's see. 10. We passed the guest presentation. At this time, Tammy, did you want to come up and say a few words? And I will bring up your screen, which I have figured out how to do here, maybe. Ta-da.
Right.
It's all yours.
Okay.
Not seeing any graphics.
Okay, so I just wanted to let everyone know, if you, oh, it didn't share? Oh, okay, hold on. We got to set to share. Hold on.
It's not what I'm looking for. Oh, here we go again. How do I get back to the screen? Oh, there we go. Okay.
No?
No. I don't know what else to tell you.
Yes, you gotta be in the room to see it.
Well, maybe, how about now? Is it sharing now?
Yep.
There we go. Yay.
Alt tab to the rescue.
Right. Sweet business. Okay, so I just wanted to let everybody know about the membership list. So if you go to membership and you go to NSRC members, then we don't care about whatever this advertisement is. So you'll see the list here. And if you scroll to the bottom, first off, this list is available in two formats. You can either do it by call sign or by last name. Okay. And what I also want to point out is if you see 2026 next to your name, that means that you are paid for the year of 2026. If you see a blank here, that means that you currently are not paid or your payment is in progress or in limbo. So we want to make sure that we get everybody. And so if you come out to the list and you see that you have a blank here, you can feel free to reach out to me or Jim, our finance guy, and we can get you all connected and set up. So, but I just wanted everybody to know that the list is out here, that you can look everybody up by last name, or you can look everybody up by call sign. So this is definitely available. So any questions on the membership list at all?
Oh, look at that. I got back to that one. That pretty much concludes the meeting. Thank you all for coming.